This is about combining management of applications and infrastructure and services based on GitOps principles. Can we manage infrastructure and third-party services and applications using the same ideas, same processes, same practices? Can we apply GitOps principles to everything, not only our applications, but literally everything? Can we ensure that all the resources, no matter what is the type of those resources, are always in sync? Those are some of the questions I will answer right now. Let me show you my artistic capabilities by drawing what we are going to do. To begin with, we have three types of resources we are trying to manage. We have infrastructure, we have applications, our applications, and we might have third-party services. And we are defining all those as code, and code is stored in Git. Our applications need to run in clusters, and clusters are collections of servers. And servers and clusters need networking and storage and a bunch of other things. All that is infrastructure, or it could be a service depending on how you manage and where you manage and who manages those things. For the purpose of today's exercise, we are going to create a Kubernetes cluster as a representative of infrastructure. And we might need, for example, a database. We might choose to run a database ourselves, or we could say, hey, I do not want to worry about that. I want to use database as a service so that somebody else, my cloud provider, manages that for me. We're going to do the latter as an example of managing services provided by third parties. So far we have some manifests stored in Git, and we want to use those manifests to create different types of resources, infrastructure, third-party services, and our applications. One approach that we've been using for many years now is to create a webhook in a Git repository so that whenever we push changes over there, that webhook would notify some processes. And those processes are typically CI/CD processes or CI/CD pipelines. If, for example, we would change the manifest of one of our applications, CI/CD would do whatever needs to be done, and at one moment it would communicate with the cluster and say, hey, you should deploy this thing. You should deploy a new release of your application. However, we are not going to do that. It's still okay to use CI/CD pipelines to build your artifacts, to run tests and what's not, but for creating and managing resources, be it applications or something else, that might not be the best idea for a simple reason, because they are one-shot executions of something. CI/CD pipeline will react whenever we change something in a Git repository, but it cannot continuously monitor the differences between the desired state, which is Git, and the actual state, which is our applications running somewhere, or infrastructure, or services, and it cannot ensure that those two states, the desired state and the actual state, are always in sync. We need a process that will monitor those two states and make sure that they are almost always in sync. CI/CD pipelines or any type of one-shot processes that are reacting only on changes to a Git repository might not be the best idea. It was in the past, it's not today. Instead, we are going to use ArgoCD. To be clear, it could be Flux as well, but I had to choose one of the tools for the example, so I'm using ArgoCD, but just in your head mentally, think of it as being Flux as well, so conceptually it's the same story. Anyways, we are going to use ArgoCD that will continuously monitor Git repository or Git repositories and the state. In this case, the state is what is running inside of our Kubernetes cluster, and make sure that those two are always the same. If I change something in my cluster, it will undo my changes because they are not the same as what is defined in Git. If I push something to Git, it will apply those changes. Anyway, it will make sure that those two states are always the same. And the two states are desired state, which is Git, and the actual state, which in this context are Kubernetes resources. So ArgoCD will communicate with Kube API, which could be the same Kubernetes API where ArgoCD is running or a completely separate cluster, that's not that important. Anyways, it will communicate with the API telling Kubernetes what to do, or at least giving it hints what should happen. And Kubernetes will ensure that our applications are running in that cluster wherever that cluster is. But our applications are only some of the resources that we can create in Kubernetes. We can also create additional custom resources, and in this context that will be, for example, a resource to create a cluster or to manage a cluster, a resource for the third-party database. If we can define those things that are not necessarily only our applications as Kubernetes resources, then we can let ArgoCD synchronize our definitions with what is in Kubernetes cluster, and that something is not always a pod. Once we are sure that Kubernetes cluster or clusters contain the resources for everything we need, not only our applications but also infrastructure and third-party services, we can use Crossplane to ensure that those resources created and managed by Kubernetes and propagated to Kubernetes with ArgoCD are created and managed as well. So the job of Crossplane is to read those custom resources like database, cluster, what's or not, and propagate that information to vendors' APIs. So today we are going to use Google Cloud for examples. Remember, it applies to any provider, it doesn't really matter, I just had to use something. Anyways, Crossplane in today's examples will communicate with Google Cloud API and propagate information from those custom resources about, hey, create this cluster or change this cluster, create this database or modify this database or destroy the database. If we are successful in this attempt, we will have a coherent way to manage everything: infrastructure, third-party services, and applications. We will define everything as code, we will store that something in Git, we will apply GitOps principles so that Git always represents the desired state and everything else is the actual state, and those two states will always or almost always be in sync because the processes will be continuously checking whether there are any drifts between those two states. So let's get going. Let's see whether we can do the hands-on part of all this, whether we can do all that in 20 minutes or less. And after that, we're going to discuss what we discovered. Before I start typing and doing stuff, let me explain what I did before I started recording this session. First of all, I created a local Kubernetes cluster using Kind. And if you're not familiar with Kind, I recently published a video, go check it up, it's above my head. Anyways, I have a local Kubernetes cluster that I can use to install and run Crossplane. I configured it to use my GCP credentials, and I installed ArgoCD. Think of that local cluster as a control plane for managing infrastructure and Kubernetes resources and what's not. It's running on my laptop, so it was easy to set it up. Basically, I spent maybe 5 minutes. Now, when I think about it, I should have shown you how I did it because it probably takes more time to explain what I did than to do it. That's it. That's all the setup. And now we can explore. What should we explore first? Yes, let's take a look at the manifest that I prepared. And the first in line is infrastructure. So if I want to create, let's say, a Kubernetes cluster, I can define it like this: GKE KTS. So this is my definition of cluster. It is using Crossplane manifests. I'm defining a GKE cluster over here called DevOps Toolkit, and where it will run, US East 1. And then I have one node pool running in 3 zones, the whole region, or I don't know, is it 3 or 4 zones? Doesn't matter. 3 zones, and that's about it. What machine type, how many, what's the maximum, minimum number of nodes? You know, the standard stuff, except that this time the standard stuff is defining Crossplane format. Apart from that, I also created a ArgoCD application. Let me show you that one. Cut controller GKE, here it is. So it is a standard, typical ArgoCD definition of an application that says, hey, the application is defined in this repository, and the path, the directory where it is defined is GKE. That's the file, the directory I showed you a moment ago. The next in line are applications. How do we define applications? We do not need Crossplane for that. ArgoCD itself can manage applications just like any other type of resources. And I have one defined here in DevOps Toolkit app.kts. And this is just a simple application that has a deployment, nothing really special because we are not going now into details about each of those topics. A deployment called DevOps Toolkit and the horizontal pod autoscaler that will scale the application from 2 to 6 pods. So that's the scale of the application we're running. It's a simple application, nothing really special. And just as for infrastructure, I have defined ArgoCD application, which is in controller DevOps Toolkit .yaml. Here it is. It's almost the same as the previous ArgoCD application. It references a repository and the directory where the application is stored. Finally, the last in line are services. And I have one defined here, DevOps Toolkit db.kts, right? We can manage services in the same way as managing infrastructure. Actually, I'm not even sure what is the exact difference, whether a GKE cluster is infrastructure or a service. Database is a service in this case. Anyways, we can define services just as infrastructure using Crossplane. In this case, I'm defining an SQL instance with this name, and that's about it. We can define additional parameters, like this is the region where I want to run this database, and this is the tier that I want to use for the database. I think that this is the smallest one. Now that everything is defined, applications, services, infrastructure, all we have to do is tell ArgoCD how to monitor. Where are the applications defined? That's what we need to tell ArgoCD. We need to give it an initial push, and from there on, it will do magic. This is ArgoCD UI. I'm going to log in with admin, obvious, right? And right now there is nothing running, no applications defined in this ArgoCD instance, and we are going to do just that. We are going to define a single application that will manage everything. And that application is this one. It says, it's just another ArgoCD application. It says, hey, this is the repository, and the path is controller. That's the directory where I have up for infrastructure, for GKE cluster, and another application for the application itself, another application for the database. So all I have to do is to give this initial root directory from which ArgoCD will spread all across that Git repository and beyond. So this is the last time I will interact with Kubernetes cluster to tell it what to do. From now on, everything will be GitOps based. Absolutely everything. Everything will be done by making changes to the desired state in Git. So kubectl apply -- file name apps YAML. There we are. Go. There we are. Now let's take a look at the UI. We can see that it already started creating stuff, right? There is the production application. This is the root application, the app of apps, and it detected that there is GKE, something called GKE, and there is ArgoCD, so it will manage itself even. And there is DevOps Toolkit, this is my application, and there is the database over here, right? So it detected, it spread across the repository, detected all the apps there, and it is creating them right now. So at the moment, I do not have a cluster in GKE, I do not have a database, and in that cluster that I do not have, no applications are running. I'm doing everything from scratch in my GCP account that currently has absolutely nothing. So this will take a few moments. I will fast forward to the end of the process because it takes between 5 to 6 minutes to create a cluster, and then a few more minutes to do everything else. Let's take a look whether it's finished. I'm going to go to my GCP account. Here we are. And you can see that the cluster is about to be created. So here's a cluster. The system is creating my cluster. And it's creating that only because I defined it as a Kubernetes resource, and then Crossplane took it over and did whatever needs to be done. Actually, cluster was created right now. And I think it should start creating nodes. Yes, it is stopping the initial node, and soon it will start creating additional nodes. There it is, the node pool is created, so I have a fully operational cluster. How about the database? Let's take a look. SQL, here it is. Was that created as well? Well, yeah, so I have my database up and running. Here it is, right? And the only thing left to check is whether my application is running. Let me tell you in advance, it's not. I think I know why. The only thing not running, the only thing that ArgoCD couldn't do is to deploy my application. And the reason for that is that the destination is set to HTTPS 1234. That's obviously not the IP of my cluster. So I need to modify the definition of the application to point to the newly created cluster. And I'm going to do that right now. So I'm going to retrieve the credentials of the newly created Kubernetes cluster, and there we are. It created kubeconfig for me. Let me take a look at the config, the current context of the config that was created. And this is the name. And we can see now that if I do get nodes or any other kubectl command, it is interacting with the new cluster that was created just by pushing definitions to Git. But I wanted the context for a different thing. I need to change the definition of the app of apps that controls the demo application that I want to have deployed, right? It needs to point to that new cluster. And to do that, the first thing I need to do is add the cluster. So ArgoCD cluster add, and then what was the name of the context? Here it is. So I'm going to add this context and I'm going to name that cluster GKE, for example. Okay, there we go. What I really want is to get the list of the ArgoCD clusters, and there it is. There is the old one, the one that is running locally in my laptop, and the new one. I will copy the address of the server and I will modify, what will I modify? Yes, controller, DevOps Toolkit YAML, to say that, hey, this server is actually wrong. This application should go to this new server, and that new server is this one. And then all that's left is to add the things and commit with the creative message something and push that something. A few moments later, ArgoCD should pick it up. It can take anything between a millisecond and 3 minutes, because 3 minutes is the pull frequency. So let's wait for a few moments and then we go to ArgoCD and see whether it's synchronized. Now if I go to the application, we can see, yeah, that's it. It's up and running. The application is up and running. Actually, it's not yet up and running, but it will be up and running soon. Right now it has only one pod created through deployment. It created a replica set. Now it has 2 pods because the HPA, horizontal pod autoscaler, was created. And that's it. My application is up and running. And if you don't believe me, actually, let's say that you might not believe me. Let's double check that. kubectl -- namespace production get pods. There it is. And you can see by the age that is 43 and 26 seconds that this is something that was created right now. Effectively, the only thing I was doing is pushing files to Git, and I get infrastructure, I get services, I get applications, I get everything inside and outside of Kubernetes cluster. Actually, as a matter of fact, I could use Kubernetes cluster as a control plane for orchestrating everything, including infrastructure, and that infrastructure doesn't even have to be Kubernetes. I could use this for any type of infrastructure, doesn't have to be Kubernetes. I will not go through the part where I would destroy something and you would see how Crossplane or ArgoCD would automatically detect the drift and synchronize it. If you're not familiar how that works, please visit the videos there in the description that show you how ArgoCD works and how Crossplane works and all those things. I'm not going into details here. I just want to make sure that the whole process, the whole idea is clear in a way. Without going into details, for details you have separate videos for ArgoCD and Crossplane and many others. Just check my channel. So I'm skipping the drift detection and auto synchronization and showing you how everything is always synchronized no matter what happens. Instead, I'm going to destroy what I created, at least the application, the service, or the application running in a Kubernetes cluster and the database. And how do we destroy things? We could destroy them by going to console and just clicking delete button or something like that, but we're not going to do that because this is about GitOps. We're going to delete the files from a Git repository. So I will delete rm controller DevOps Toolkit DB, And I'm going to delete the other one as well. So I'm leaving the cluster working because some other applications might need it, but I'm deleting the database. Database is a service, and I'm deleting the application itself that is currently running in the cluster, in Kubernetes cluster. Actually, I'm not deleting any of those things. I'm deleting the manifests, and then ArgoCD should do the work. Let's check it out. Let's check it out. So I'm going to add those files and commit those files, delete everything, and I'm going to push those files. Now we wait for a few moments, and let's actually go back to the ArgoCD UI and see what's happening. There we are. If I go back to the root, now my application here, DevOps Toolkit, is running, and DevOps Toolkit DB in the service, SQL managed by Google Cloud, they're still running, right? And if I go here, I can see that the database is there, right? So nothing really happened. And the reason why nothing happened is because ArgoCD did not yet synchronize, did not yet pull new information from Git. So let's wait for a few more moments. And there we are. Now it is out of sync and it is progressing. And what is it doing? We can actually go here and see what it's doing. It's deleting stuff, right? There we are. It is deleting the application and it is deleting the database, and soon they will be gone. Let's go back to Google Console and check the database. There we are, database is no more, and I just deleted files from Git. Let's see the application as well. Is it running? kubectl -- namespace production get pods. Come on, yeah, empty, deleted. I can create stuff, I can modify stuff, I can delete stuff. Doesn't matter whether it's infrastructure or services or my own applications, and they will always be in sync with what is in Git. And if I delete stuff from Git, then stuff is deleted in real world. That's it. Let's go back to the big screen and discuss what we just experienced. In this video, I did not go into details how to work with ArgoCD or Crossplane or Git or this or that. Instead, this is more like a culmination of many other videos that I did in the past. We got a unified way, at least from the process perspective, to manage everything. And everything is infrastructure, third-party services, and applications. And that process is GitOps based. We are managing everything by pushing changes to Git repositories. And we have ArgoCD that is pulling those definitions and making sure that the desired state, the manifest defined in Git, are the same as the actual state, or actually that the actual state is the same as the desired state. But since ArgoCD can manage only Kubernetes resources and not infrastructure, not the things outside Kubernetes, we added Crossplane. So ArgoCD, among other things, is managing Crossplane CRDs or Crossplane definitions, and then Crossplane takes it over and manages everything happening outside our Kubernetes cluster, or the Kubernetes cluster where Crossplane is running, right? Because as you saw in the example, Crossplane created a second Kubernetes cluster, and it can create a third and a fourth and a fifth, and it can even manage the cluster where Crossplane itself is running. The important thing is that I had to make a choice which tools I will use. I chose ArgoCD for synchronization between Kubernetes and Git repositories, but it could be Flux as well. Similarly, I chose Crossplane to manage everything happening outside of the domain of Kubernetes resources, and that could be Terraform or Pulumi. Now, it would be harder with Terraform and Pulumi for a simple reason, because A, they do not allow us to create Kubernetes resources, so we would need to figure out a different way, something that is not ArgoCD. And B, Terraform and Pulumi do not have a way to detect drifts and autocorrect the current state compared to the manifests, right? They are one-shot agents that do something when we tell them to do, but do not monitor the state of what they did and correct it continuously. We could make those work in a similar way as what I did with Crossplane. It would involve a few additional steps. It might not be as effective, but it can be done. I can show you how to do the similar process with other tools, but you have to let me know in the comments what those other tools are, and I will do my best to do a variation of this video with the tools you like. You just need to tell me which tool you prefer for infrastructure and for services, and which one for applications, and I'll do my best to do it. That's about it. Remember to like and subscribe. Thank you so much. See you next time.